A couple of times so far we've seen how if we have a force system that we can represent it in terms of its resultant force and resultant moment in a given reference point. Say, as I've shown here, we have a body with a force system and a reference point A, and that results in a resultant R and a moment resultant about A. And we've also seen how sometimes we pick other reference points and we get a different expression for the resultant characterization of the force system. And what I'd like to do now is just simply look at what that general relationship looks like in terms of, given a force system, resolving it with respect to one point, say point A, and what the general relationship is to the resolving that same force system at a second point. So let's start off here. We have a force system with a set of forces Fi, and they've been characterized by a resultant R and a moment resultant MRA. And what I'd like to do now is consider a second point B, and I want to find the characterization R and MRB in terms of my first characterization in the point A. So let's go ahead and draw in a few vectors here that will help us do this. So let's draw in the vector from A to B, and then let's consider an arbitrary force Fi located at a location I. We have the vector going from A to I, and let me also draw in the vector going from B to I. Okay, so with that bit of geometry there, note that I can write MRA in terms of the two vectors RAB plus RBI. If I expand this out, I have RAB cross Fi plus RBI cross Fi. The second term here is nothing other than MRB. It's the moment about B of the force system that I'm looking at. And in the first sum, I can pull RAB outside of the summation since it doesn't depend on the point. So I have RAB cross the sum of Fi, which is just the resultant force. So this gives me a final characterization, or the relationship between the resultant moment in a point A is equal to, let me write it this way, the moment resultant in the second point B plus RAB, so the vector going from A to B, crossed with the resultant force. So it gives me the general relationship that connects a resultant moment in one point with a resultant moment in a second point. Note that if the resultant happens to be equal to 0, so in other words I'm in the pure couple case, then the two moments are the same, the two resultant moments. So MRA equals MRB. So this is an example of a fact that we saw earlier, that when you have a pure couple, the reference point doesn't matter. You'll always get the same result.